So I'm going to introduce Nick Miller. This is our presenter for the day. Nicholas is an innovative career entrepreneur who has founded a number of successful high-technology companies in the US and Canada in the software, wireless, security, and internet sectors. Nicholas is a well-known authority and communicator in the high-technology industry and frequently speaks at technology and business events throughout the world. Nicholas is a strong advocate for action to address the causes and effects of climate change and has been trained by Al Gore to deliver an updated version of his Inconvenient Truth to Canadian audiences. Nicholas was born and educated in Britain and is married with one son who is currently studying political science at SFU. So here we are giving back. Thank you very much, Nick, for presenting for us.
Not surprisingly, my son's absent today, so. Well, thanks to everybody very much for coming, and thanks to SFU and all the sponsors for organizing this event. So as Candace said, I was trained by Al Gore earlier this year in Montreal. The Climate Project is an organization that was put together right after the movie was made. I told a story on, I don't know if any of you heard the interview I did on the radio at SFU here, but my wife and I went to see the movie, the Inconvenient Truth movie. And I was, obviously, as we all were, I was very, very impressed by the movie. And I'm driving home with my wife, and I said, you know, what he needs to do is get a bunch of guys like me who stand up selling stuff, doing PowerPoints all day long, to actually do this presentation so he could sort of clone himself. And I thought this was a really clever idea, and got home, went on the web, and immediately discovered that they'd already thought of that, needless to say. And in fact, they had put together a program called the Climate Project in the US, and they were recruiting people to volunteer their time, like me. Also, anybody, I mean, everything from people who actually know something about climate science to people who are not climate experts. I'm certainly not a global warming or a climate science expert, but I do a lot of communicating for a living. So I applied, and it turned out that they weren't looking for Canadians at the time. They actually did recruit, I think, 4 or 5 people from Canada who went to Nashville and were trained. And then later on, they decided that what they wanted to do was do the same thing in Canada that they had done in the US. And so earlier this year, and I think it was April in Montreal, they organized, they actually sent me an email and said, "Are you still interested?" And I said, "Well, yeah, sure, I'm definitely interested." And so a number of us were selected. Apparently lots and lots of people applied, and for some bizarre reason I got chosen. And went and got trained, and it was a really fascinating time to spend the whole weekend with Al Gore and get to speak to him and get his take on, I mean, it was great because he was able to say what he really wanted to say. You know, a lot of times he can't say publicly because he's a political figure what he'd really like to say, but he was really forthright and went through the presentation. And so now whenever I have some time and whenever everybody wants me to do it, I'll go and give an updated version of the presentation, which I'm going to do now, and I hope you all enjoy it. Later on, one of my other co-presenters, Amber Church, is going to be here. She's actually studying at SFU. She teaches actually at SFU, and she's studying glacial erosion. And she is a climate change expert, and she's going to be here later on for the Q&A session. So Amber and I will both take questions at the end. So getting into the presentation, let me just see if this is going to work. Here we go. So this is a great shot. This was one of the first pictures that most of us ever saw of the Earth from space. And I remember this quite well. I was a child at the time. It was the Apollo 8 mission. It was a very, very exciting time because we were getting ready to go to the moon. And the story of this shot is that the spacecraft, this was the first time they'd actually gone around the back of the moon. So it was the first, they didn't actually land on the moon in Apollo 8, but they went all the way to the moon, went round the back of the moon, and then just came back. I think they did a few orbits and then came back. But it was very, very exciting because, of course, nobody had seen the back of the moon, and we didn't, you didn't really know there were dragons back there or what was going on. So it was very, very exciting. The spacecraft went behind the moon, and as it went behind the moon, it lost radio contact with Houston, with Earth. And it was a time of great tension, and everybody, are they going to come out the other side, and what's going to happen? And of course, needless to say, at the appointed time, they did come around the back of the moon and came back into radio contact. And just as they did, they saw this wonderful image of the moon. And a rookie astronaut, Bill Anders, took out a camera and snapped this shot. This shot became known as Earthrise, and really sort of imprinted on the human consciousness. And within 18 months of this picture appearing, the environmental movement was born. So this is a really seminal event, and it was just a wonderful shot. This picture is another shot that we're all very, very familiar with. This picture was actually taken on Apollo 17, and it was actually the last picture that a human being ever took of the Earth from space, the full Earth from space, other than the shots that the astronauts in the space shuttle do. And what's really cool about this picture is that it was a sort of a rare situation where the sun was directly behind the spacecraft, so the full disk of the Earth was displayed. And it's a really wonderful shot. It's actually the most popular picture ever in human history. So this has been published more than any other picture. So whenever you see a washing machine ad with a picture of the Earth, it's this shot. And it's a really wonderful shot. This is an interesting time-lapse shot. This was actually taken by the Galileo spacecraft just as it was leaving Earth's gravity. And Carl Sagan, who was running the show at that time, commanded the spacecraft to turn its cameras back to Earth. And they took a series of images, I think about over a 24-hour period, they took a series of images and then made it into an image for every second, an hour every second. So this is a 24-second image. It shows a complete rotation of the Earth. This shot is a very interesting shot. It's a composite picture. It's an actual real picture of the Earth, but it's made up of 3,000 composite shots. It was done by a fellow called Tom Van Sant, and he managed to assemble a bunch of shots that were taken of the whole Earth when there were no clouds in the way, obviously. So it's the Earth minus the weather. And it's a really fascinating image, actually, because you get to see the whole Earth. And then this is the same image, of course, made into a Mercator projection, flattened out. And Al Gore tells a story about this when he gives the presentation, about being in sixth grade with a classmate who he had a teacher who would pull down a picture of the Earth like this in front of the class on a sort of roller blind thing. And one of his classmates stuck his hand up and said, didn't these two countries once fit together? It looks like they just sort of fit together. And the teacher said, well, what a ridiculous thing to say. That's the most ridiculous thing I've ever heard. Of course they didn't ever fit together. Well, it turns out that he was completely wrong, and we now know that they do fit together, or they did at one point in time. So the point here that we're making is that the teacher was sure of his facts at the time, and he was actually correct. The prevailing science at the time didn't know anything about continental drift, and they thought, well, yeah, that's ridiculous. Of course the continents don't move around. But it turns out that he was wrong. And there's a great saying by Mark Twain that says, what gets us into trouble is not what we don't know, it's what we know for sure just ain't so. And that's really the situation that we're in with global warming. So there are a lot of people out there who are quite sure that there's not a problem, a diminishing number, but they don't have a lot of the data. It turns out that the Earth's atmosphere is incredibly thin relative to the globe. And Carl Sagan once said that if you took a globe, a normal globe like you might have in your living room, and varnished it, the thickness of the atmosphere is about the same as the thickness of the varnish on the globe. So it's very, very, very thin. And it turns out that, in fact, we can impact on that atmosphere. It's not something that we can have no impact on at all, which really brings us to the science of global warming. And I'm not going to spend a lot of time on this because I know that you all are probably familiar with this, but the basic science is pretty simple. Solar radiation from the sun in the form of light waves hits the Earth. It passes through this our very thin atmosphere. Some of it gets trapped by the atmosphere and it warms the Earth up, which is a good thing. And some of it is radiated back. The low-frequency radiation is radiated back into space in the form of infrared radiation, again, with some being trapped by the atmosphere. And this is what keeps the Earth nice and warm and comfortable and livable for human beings. It turns out that another way to look at this is a sort of tale of two planets. If you look at Venus and Earth, both Venus and Earth have approximately the same carbon composition. The difference between the two is that on Earth, biological processes have sucked a lot of the carbon dioxide out of the atmosphere. So Earth has a relatively thin atmosphere. Venus, on the other hand, has an extremely thick atmosphere. Now, if you compare a reasonable average day on Earth, it's 15 degrees centigrade. A typical day on Venus is toasty, 457 degrees centigrade. Now, some people might say, well, that's because Venus is closer to the sun. You know, it's got nothing to do with the atmosphere. Well, it turns out that Mercury is even closer to the sun than Venus. It has a very, very thin atmosphere, and it's cooler than Venus. So we actually know that the thickness of the atmosphere is really what causes global warming. And of course, now we're impacting on it massively by pumping huge amounts of carbon dioxide into the atmosphere. And what's really happening as a result of this is that this atmosphere here is starting to thicken up. You can't really see it in the slide. And that's causing more radiation, to be reflected back in. And so the Earth is heating up. So as this atmosphere thickens, it's just like having a thicker comforter on your bed. You just get hotter. And that's exactly what's happening to the Earth. Well, this is a sort of a graphic that illustrates really a curve, and I'll talk about it at more length in a minute. It's actually the Keeling curve, and this is what really inspired Al Gore to get involved with the whole sort of climate change movement. And it was invented or discovered, if you like, by one of his professors, Roger Revelle. And what he did was they started to launch in 1957 balloons into the atmosphere in the middle of the Pacific, way, way out into an area where they knew it would be not affected by pollution from the land, from countries. And what they discovered was that the CO2, as they measured it seasonally, went up and down, but they started to notice that it was just increasing over time. Well, it turns out that the reason for this is simply because of the following. If you look at a map of the Earth, there's a lot more land in the north than there is in the south. And the process that's going on really is pretty simple, but perhaps not all that obvious. As the Earth tilts towards the sun, as the northern hemisphere tilts towards the sun in the summer, it gets warm, the plants all come out, and carbon dioxide is absorbed by the plants, and it has a net lowering effect of CO2 in the atmosphere. Now, obviously, in the southern hemisphere, the opposite is happening. When it tilts towards the sun in their summer, in our winter, the same thing occurs, but because there's less land, there's less vegetation, so there's less CO2 absorbed. So what happens is as the Earth tips, as the northern hemisphere tips towards the sun in the summer, there's a big absorption of carbon dioxide, and there's a smaller release of carbon dioxide in the south. As it tips the other way, there's a correspondingly smaller absorption of carbon dioxide and a larger release of carbon dioxide in the north. So the net result is that the planet sort of breathes in and out seasonally. So it's sort of each year as it tilts, there's more carbon dioxide, then this, then more, then less. And that's really what caused the Keeling curve to occur. Now, Al Gore spent a lot of time over his entire term in office trying to do things like getting a Clean Air Act implemented. He eventually ran for president, wasn't elected, finally got into the White House, enacted the Clean Air Act with Bill Clinton. All this time, the Earth was breathing in and out, and the level of carbon dioxide was going up and up and up in the atmosphere. This curve, unfortunately, this slide was made for Al Gore, who is from the South and speaks much more slowly than me, so it has a sort of a timing issue with it. But you'll see that it just goes on and on and on, and the atmosphere each year is getting thicker and thicker and thicker, in and out, up to the present day. And the result of this has essentially been melting of glaciers, and later on Amber Church is going to be here, who's a co-presenter of mine, and she's studying melting glaciers in northern BC, and she can really talk about that a lot. But this is what's been going on. This is what the Helm Glacier looked like in 1929. This is what it's like, was like in 2002. It's even worse today. Similarly, the Illecillewaet Glacier in northern BC, 1898, nice big glacier. Today, it's gone. And you can see how it's receded year by year. In fact, if you look at a graph of receding glaciers in Canada, it's just a dramatic reduction in these glaciers over time, and it's just getting worse and worse and worse. More examples, I'll skip through these quickly. In Alaska, then now. Again here, the Columbia Glacier. And what's happening is that these glaciers are carving off pieces of them, and it's falling into the water and draining out into the sea. We'll talk about this a little more later on, but this is what's causing ocean levels to rise. It's when land-based ice melts and falls into the sea, it obviously makes the sea go up. And this is another problem that we'll talk about a bit later on. More examples here. This is a glacier in Peru. This is a really striking shot. This is the Uppsala Glacier in Argentina in 1928. Now it's a lake. La Paz, Bolivia. This is a huge problem. What's happening in Bolivia is that in La Paz, about a third of their drinking water actually comes from glacier melt. So melting glaciers is actually causing huge problems in La Paz because as these glaciers melt, there's not going to be any runoff, and they won't have any their drinking water supply will be dramatically reduced. Here's a great old postcard shot of the Hotel Belvedere on the Rhone Glacier, and this is what it looks like now, not quite such a nice view. This is a great shot. This is a 5,000-year-old man that appeared out of a glacier in 1992. When David Suzuki, when we were at the training in Montreal, saw this shot, he said, "Our ancestors are coming back to tell us to do something about this problem." More shots, the same story. I'll just skip through these quickly because it's just the same story all over the world. In the Himalayas, it's again a very, very serious problem. It turns out that a huge portion of the world depends on the Himalayan glacier melt for their drinking water. You can see the Hindus, the Ganges River, Brahmaputra River, the Salween River, the Mekong River, and the Yangtze River into China, the Yellow River. And what's happening is that these glaciers are again receding. 40% of the world's population depends on water that's running off from these glaciers in the Himalayas. And as they recede, this is going to cause an enormous water shortage problem in Asia. And ironically, it's going to cause a lot of people who live in Asia to not have enough water, and it's also going to cause a lot of them to be underwater as ocean levels rise as a result of this. So it's a very, very serious and striking problem. Here's a great shot of Kilimanjaro in Africa. I was actually there around this time, and that's what it looked like. This is what it looked like in 2000. And then recently, in 2005, you can see the snows of Kilimanjaro are almost completely gone. In fact, this is a guy called Lonnie Thompson, who's a friend of Al Gore's. That was the only piece of ice. He found this spear of ice on the top of Kilimanjaro that was all that was left. And here he is. Lonnie Thompson has spends a lot of his time studying glaciers and drilling ice cores into glaciers. And all over the world, here he is doing it in Peru. And what they're able to do is when they drill these ice cores, they can actually look at the ice down through the ages, almost like rings in a tree. And Al Gore said that when he was shown an ice core by Lonnie Thompson, and he could actually see with the naked eye when the US enacted the Clean Air Act. You could actually see it with the naked eye in the ice core. That's how dramatic it was. And what they're able to do is essentially look into these ice cores. Here's another shot of a sort of a side view that they were able to drill down. You can see that each year it's like rings in a tree. And they can actually look at the composition of the little air bubbles in these ice cores. And they can determine exactly how much CO2 was in the atmosphere at a particular moment in time. They can do it very accurately. And by comparing, and I don't fully understand this, Amber can explain it to you better later on, but by comparing a couple of isotopes of oxygen in that little bubble, they can actually determine the temperature, the prevailing average temperature at the time. So we can determine very accurately what temperatures look like. And this is essentially what you see. Here's a thermometer, and here's where we are now. And you can see there's been dramatic increases. Now, skeptics will always talk about a warming period in the Middle Ages, and they're right, it's right back here. But you can see here, rather, it's nothing like what we're dealing with now. The other thing that you see is when you track temperature and carbon dioxide over a period, you see that they match almost exactly. Again, it's like the two continents example that Al Gore's pal mentioned in grade 6. So we've started to do the same thing now in the Antarctic. And in the Antarctic, we're able to go back, this slide actually goes back 600,000 years. They can now go back almost 1 million years in time. And this is what we see. Variations, fluctuations in CO2 concentrations, and a similar matching fluctuation in temperature. And there are 7 ice ages. You can count them all the way back from now. You can see them. And incidentally, the difference between this and this is a mile of ice over your head. So there's a huge difference. Unfortunately, here's where we are today. So we're at almost 400 parts per million. It's never been higher than about 290 or so parts per million. We're now at almost 400 parts per million, so we're almost 50% higher than we've ever been in recorded history. And this is an enormous problem, but it gets worse, unfortunately, because if we carry on the way we are after 40 more years of use of energy in the current method, this is where we're going to be. Now, again, if this is a mile of ice over your head on the cold side, imagine what that is on the hot side, and imagine what that would be. I need Al Gore's lifter machine to do this, but imagine what that would be on the hot side. It's pretty obvious. And I have to say that when I saw this graph in the movie, this was what galvanized me. I thought, this is a big problem. I mean, this is not rocket science. When you look at it, it's really obvious, and it's really clear that we need to do something about it. And this is really what inspired me to get involved. And in fact, if you now look at what's happened, the 10 hottest years on record have occurred within the last few years. 9 of them have occurred within the last 10 years. And this is causing tremendous heat waves, 50 degrees centigrade. I don't know if any of you have ever experienced anything like that. I was in Las Vegas once when it was, I think, 114, which is nothing like 50 degrees centigrade. 50 degrees centigrade temperatures, half the boiling point of water in India. 1,400 people died. In Pakistan, the same sort of thing, 52-degree temperature rises. And we're predicting annual temperature changes in Canada to be pretty significant. And you can see, I'm going to get Amber to explain this because this is a sort of a scientific chart that's a little bit cryptic. But they tend to measure temperature in sort of 30-year blocks. It's a bit, although in the second case we're talking about a 20-year block. But they're essentially saying that there's going to be tremendous changes in temperature in this area here, anywhere that's these sort of colors. So you can see what's going to be going on here. This is also affecting the ocean. This is what you would normally expect the ocean temperatures to be based on normal fluctuations that you would expect in ocean temperatures. This is what scientists using computer models predicted that the ocean temperatures could change to due to human causes. And this is what's actually happened. So a tremendous rise in ocean temperatures. And this is causing tremendous weather events, hurricanes. It's not an accident that we're seeing a lot more hurricanes and a lot bigger hurricanes. The hurricane this year that hit Houston was not particularly powerful, but it was massively wide, hundreds of miles wide. It was an enormous storm. And these storms are caused, essentially, weather is driven by ocean currents and ocean temperature. So these storms are really created as a result of this. I'll skip through this fairly quickly because I don't want to use a lot of time on this, but we're all familiar with these various enormous hurricanes. New record set for typhoons in Japan. They never thought that we could get hurricanes in the South Atlantic. Well, we got one in 2004. It's also increasing the incidence of tornadoes in the United States. A new record in 2004, really devastating consequences, and we're seeing this more and more and more almost every year. This is occurring. Multiple tropical storms in the summer of 2005 in the South Atlantic, in the North Atlantic rather. Hurricane Emily here. Dennis, huge devastation. This is the largest oil platform in the world, the BP Thunder Horse platform. It was completely toppled. They never thought that could happen. Another oil platform washed up on the beach. These people here standing on the bank thinking, that's not supposed to be there. What the hell's going on? Stuck under a bridge. So as the oceans heat up, hurricane intensity grows, wind shear grows, and more moisture is evaporated out of the ocean, which causes more precipitation. And then, of course, in 2005, we had Katrina, which this is a great animation. You see it starting just to the south of Florida. As it crosses the Florida Panhandle and comes into the Gulf, it hits really, really warm temperatures. Look at the size of the eye of that hurricane. So what happened was, as the eye came over, as the storm came into the Gulf of Mexico, the extremely hot, I was looking at a NOAA chart, I wish I had it, showing typical surface temperatures, ocean temperatures in the Gulf. It's shocking. It's like bath water. It can get really, really hot. So as soon as the hurricane hit that water, it really spooled it up, and the results were absolutely devastating, as we all know. And again, I'm not going to beat this to death. We all know. Everybody remembers what happened. It was a horrendous event that America was completely unprepared for and then completely bungled the response to. So this is a great phrase that one of my favorite people, Winston Churchill, said: "The era of procrastination, of half measures, of soothing and baffling expedients, of delays is coming to a close, in its place we're entering a period of consequences." He was, of course, talking about Germany at the time and the rise of the Nazis, but we're in a similar sort of a situation now where we really need to act. We've got to do something. This is not something that we can continue to just ignore. And I'll skip through these slides again really quickly because I want to get to the meat of the presentation here. They ran out of letters. They named these storms with people's names. In 2005, they ran out of people's names. They got to Z and had to start with the Greek alphabet. That's how bad it was. That doesn't happen very often. So we got to Delta. Epsilon went all the way to Zeta. And the insurance industry has noticed this. There have been tremendous losses as a result of this. And here in Canada, the same thing. Year by year, weather-related disasters and losses have increased. We remember the ice storms in Quebec in the late 90s. This is an interesting slide because it shows you what's going to happen to us. So here in the Pacific Northwest and in Atlantic Canada, we're going to get a lot more precipitation. But basically, the precipitation patterns are going to change all over the world. What this slide doesn't show so well is that the deserts are actually going to move. And as we get more precipitation in the north, what happens is in the belts above and below the deserts, above the Sahara Desert, for example, that's going to actually move up. So a lot of the Mediterranean areas are going to have a lot less precipitation in the north of Africa and in the central United States. I went to a talk by Gwyn Dyer earlier this year at the K-Meek Center in West Vancouver. And I turned up expecting him to talk about conflict in the Middle East and so on. And it turned out the whole presentation was about climate change. And he's just written a great book, which I'm just starting to read, called Climate Wars. He thinks that climate change is going to be the greatest creator of conflict in this century. And it's a really, really serious problem as countries become unable to feed their populations and other parts in the world get inundated with water. There's going to be a tremendous amount of movement of population, and that's going to cause a lot of friction, he thinks. So there are a lot of other effects as well. This is a slide that we did for Atlantic Canada. There's been a tremendous amount of a noticeable rising of ocean levels in Atlantic Canada. I'm going to skip through some of these slides here. Again, all over the world, the same thing's happening. In Japan, huge rainfall. And as Al Gore says, it's like a nature walk through the book of Revelations in Europe these days. And talking to my mum and dad over in England, they've had a lot more rain and a lot more precipitation than they used to have in the old days. Here's a chap out for a walk in Switzerland. Same thing all over the world. So this is a pretty obvious pattern. It's pretty clear what's going on. In India, they've had enormous rainfall, like they've never had before. This is rush hour in Mumbai. 90% of the city underwater. Just a horrendous situation. In Indonesia, the same thing. Ghana. Here we are in Mexico, same thing. Really all over the world. Just locally down the road in Chehalis, Washington, there's the Walmart, mercifully underwater. But anyway, Ontario, the same thing. You don't want to see this when you're pushing back to the runway. Doesn't inspire confidence. Apparently, these fellows were actually recovering license plates for some reason in China. We don't, but again, tremendous flooding. And Sichuan, look at that poor little chap being pushed along. But it can also cause drying as well. So as the Earth heats up, we get a lot more precipitation in some areas, but we actually get drying in other areas. And essentially, this is what's happening. As we get warmer temperatures, the ocean evaporates, but also moisture is sucked out of the land. And in Africa, this has had devastating consequences. In Lake Chad, which was an enormous lake in the 70s when I was in Africa, in the Niger Darfur region, now it's basically completely evaporated, removing a very, very important source of water for the people and fish. And it's just a dried up lake bed now. This was a big river in Australia. Now a girl can jump over it. This was an interesting slide. If you looked at all of the water in the world, that's how big it would be. So, when we look at this is sort of obvious, really, but when you look at the Earth, it's all blue, and you think, well, there's loads of water. Well, the water's not very thick. There's no depth to it relative to the size of the Earth. So there's not really that much water to start with in the world. And that's relatively speaking how much there is. Which brings us really to the first canary in the coal mine, and it's the Arctic. And this is the Ward Hunt ice shelf in the Arctic, which broke up in 2002. It cracked in half. Here's a shot of what are called drunken trees in Alaska. What's happening is the permafrost is melting, and as a result, the trees just fall every which way, and even graveyards, all the tombstones are falling over. A building here collapsed. Again, the melting of the building was built on the permafrost. The permafrost melted, the building collapsed. Roads are getting heaved up as a result of this as well, making transit of them difficult. This is a shot of actually northern Russia, where they use ice roads to transport goods and equipment for their oil fields and other things. Well, what's happening is these trucks are all getting stuck because the ice roads are melting. And it's causing, same things happening in Alaska, incidentally. So what's really going on here is that the ice is diminishing in the Arctic. And this is a great shot of a US nuclear submarine surfacing through the ice. It turns out that the US has been studying the thickness of ice in the Arctic for many, many years, pretty much ever since they've had nuclear submarines going underneath them. And the reason for that they've done it is they can only surface if the ice is less than a meter thick. So they needed to keep track of exactly how thick the ice was everywhere, so they knew where they could poke the conning tower up through the ice. All of this information was classified and kept secret. Al Gore actually got to go on a nuclear submarine and eventually convinced them to release the data, and the results were really horrendous. I don't have the graph here, I don't think, but again, it's a sort of precipitous drop-off of ice that they've known about for a long time but have not told anybody about. And in fact, if you compare 1980, that was what the ice extent looked like in 1980 in the Arctic. This is what it looked like in the summer in 2007. Again, this is the average September ice extent in the Arctic. There was a record low in 2005, and some people are now saying that they think that the ice is going to be completely gone in the Arctic within 5 years. So if you want to go to the North Pole, you'll need a boat. Here's some comparisons that are interesting. Unfortunately, we don't have one of Canada, but that's just so you can sort of bigger than a bread box, compare it to stuff that you might know. That's what it looked like in 1980, which is equivalent to that much of Europe. This is what it was like in 2005, which was equivalent to all of England, Spain, France, Germany, Switzerland, Belgium, all of that gone. A huge amount of ice gone. Here's the chart. I was wondering if I had that. And you can see there's been a precipitous drop-off in 2005, and it's actually just going south at a high rate of knots. It's now, in 2007, there's been a precipitous, almost an exponential drop-off. I'll skip through this and get to... Here's the Ailes ice shelf collapsing in 2005 at Ellesmere Island. This was a huge ice shelf. So what's going on really is, the reason it's sort of exponential is the following. The Arctic, it really acts like a big mirror, and most of the solar radiation that hits it gets reflected. But as it starts to melt due to global warming and gets smaller, less of the solar radiation is reflected. Actually, 90% of the solar radiation that hits ice is reflected. 90% of the solar radiation that hits the ocean is absorbed. So what happens is you get a sort of a feedback loop and a runaway effect. As the ice starts to melt, it gets smaller, the ocean starts to warm up. The warmed ocean melts the ice faster, there's even less of it. You've got more warm ocean, and the thing literally sort of runs away, which is why we think we're seeing this precipitous drop-off in Arctic ice. And of course, this is having devastating effects on polar bears in the Arctic. Many of them are being found at sea, drowned, unable to find ice to swim to. This is a great but sad shot. So it turns out that, again, you can see the graphic here. It starts to shrink slowly, and then as the ice pack diminishes, less solar energy is reflected, more is absorbed by the ocean, and it actually becomes a hot spot. In fact, there's more heating of the oceans happening at the poles than anywhere else on the planet. And this is going to have a huge impact on our climate and on our weather and so on and so forth. And we'll talk about this a little more in a second here. It turns out the climate is a non-linear system. This is essentially what's going on. As the globe heats up, heat is really transferred from the equatorial regions to the pole. That's how the heat is dissipated. And this transfer of heat really creates ocean currents. So it's really the delta, the difference in between the temperature at the equator and the temperature at the pole that's really the pump, if you like, that's driving these ocean currents. Well, in 2000, the average temperature of the Earth in 2006 was 15 degrees centigrade. If we had a 3-degree rise in global temperatures, this actually translates into a 1-degree rise at the pole, at the equator, and a 7-degree rise at the pole. It's not evenly distributed. Now that's a huge difference. That's a massive delta. And what's going to happen as a result of this is really sort of unknown. I'll give you a little demo here. This is where my presentation can go horribly wrong, actually. But this is an idea. So what happens is if you imagine the currents as sort of going like this, when you get that big a change, they'll suddenly flip. They can just go like this. So we really have no idea a change of this magnitude. We have absolutely no idea what's going to happen. It's not really very well understood how the ocean currents go where they do anyway. But what we do know is that it's driven by this change in temperature, and if that changes that dramatically, it's difficult to know what's going to happen. It's not going to be good, though. That's pretty obvious. And one of the things that this is affecting is a shift in the seasons. So this was a study done in the Netherlands. You can see in April 25, that's peak bird arrival time. In June 3rd, that also coincides with the peak bird hatching and the caterpillar season. Well, what happened was that as things started to warm up, there was actually a shift in the caterpillars started to come earlier because it was warmer. The birds tried to catch up, but couldn't. So now the bird populations are in peril because there aren't enough caterpillars to feed them. They're coming too late. The caterpillars have already gone. So these sorts of effects are really causing enormous problems, and it's resulting in really a change in invasive species. And a classical example of that right here in BC is western pine beetle damage. I don't know how many of you have driven to Kelowna recently, but I hadn't been there for a little while. I drove there a couple of weeks ago. I was absolutely horrified. Just from the highway, you can see the devastation that's been done by western pine beetle. And I'm told that if you fly over northern British Columbia, it's much worse. It's absolutely horrendous. Now, what's really bad about this is that not only is it killing the pine trees, which that's bad enough, but it turns out that the pine trees, when they're absorbing carbon dioxide, that carbon is stored in the tree. When you kill the tree, all that carbon gets released. So it's a double jeopardy situation. So not only are these trees being killed by the pine beetle, not sucking up CO2 anymore, they've now flipped, and all the CO2 that they had sucked up is now being released. So it's a really horrendous situation. It's also causing species extinction. The yellow frog is going extinct. It may very well result in Canada's first major species extinction. The Perry caribou is likely to go extinct here in Canada. So it turns out that these changes are actually causing a massive species loss. We're actually in the middle of an extinction event that's as bad as when the dinosaurs died out 65 million years ago. So there's a massive, you can see the way this curve has gone, a massive impact on species. Coral reefs are being badly affected. The thing that makes coral reefs colorful is a creature called zooxanthellae. I hope I said that correctly, but they actually sort of cling to the coral reefs and give it its color. What's happening now is because of changes in ocean temperature and ocean chemistry, they're being killed and the reefs are getting bleached out. which is obviously impacting on fisheries and local economies and so on and so forth. We're also seeing enormous algae blooms because of changes in ocean temperature. It turns out that there are some massive jellyfish that are being seen in Japan that were never seen before, that like the change in ocean chemistry. So they're doing very, very well, but they're eating all the fish out. They're damaging the fisheries. Vectors for emerging infectious diseases, all sorts of things. I remember visiting Nairobi many years ago in Kenya, which has been specifically placed so it's just above the mosquito line, so you don't get bitten by mozzies in Nairobi because it's at, I think, 5,500 feet. Well, now you do, because everything's warmed up. The mosquitoes have come up. So a lot of cities that have been specifically placed so that people won't get bitten by mosquitoes, now it doesn't work anymore. People are getting bitten by mosquitoes, so it's causing death and disease and so on. We're seeing the emergence of many, many new diseases since 1976. And again, I won't go through them because we've got a lot to do, cram in an hour here. The West Nile virus, really unknown in North America. It's now moved right across the continent, so that it's extending now all the way from the east coast of the United States right out here to Vancouver. Something that we never had before. So this brings us to the other canary in the coal mine, which is the Antarctic. Again, we're seeing the same sort of thing, a tremendous warming in the Antarctic, impacting on penguins. Here's something that Mercer said. Turns out this is happening. We're seeing a tremendous breakup of the ice shelves in the Antarctic. In particular, in this peninsula up here, the Larsen B ice shelf in particular it was just collapsed a few years ago. And it really mystified scientists because it happened so quickly. You can see these little black spots here. They look like we're seeing through the ice. We're actually not. They're little melt pools that people observed, that the scientists observed in the ice. And what happened was the ice all of a sudden started to break up. Now these, if you were to look at these ice shelves, this is what they would look like. They stick 700 feet out of the ocean, and if you were to fly over it in a helicopter, this is what you'd see. These majestic ice shelves. This is what's starting to break up and melt. So this isn't like a skating rink. This is the bit that you see above the water is 700 feet high, and then the piece below, these are thousands of feet thick. Massive, massive ice shelves. Now these ice shelves are floating, but if you look behind, about 25 kilometers behind these ice shelves at the mountains back here, these ice shelves are holding land-based ice on these, back on these mountains. Now when the ice shelves melt, it doesn't make the water go up. It's a problem, but it doesn't make the ocean go up. But as the ice shelves move away and this land-based ice starts to fall into the sea, that's going to cause a problem. And again, we'll talk about that a bit more later. This was the breakup of the Larsen ice shelf, which in a period of just about 30 days, just completely went away. And scientists thought at the time that this ice shelf would take at least 100 years to break up, even with global warming. The same thing on the other side of the peninsula, the Wilkins ice shelf earlier this year. Here are some great shots taken by the BBC. It looks like pieces of styrofoam, but again, these are 700 or 800 feet high and extending almost 1,000 feet thick. Wilkins ice shelf just broke up. And we've got a little animation here that you can see, a shot from the air. This is a really, really great shot. And again, these are 700 feet above the water, but thousands of feet thick. You'll see some pieces on their side in a minute, and you can see the blue bit there. This bit is the bit that's below the water. This is the bit that you're seeing sticking up. So these are enormous, enormous ice shelves that are breaking up. again, I'm going to skip through this because we're running short on time. And again, as these ice shelves break up, land-based ice eventually can start to fall into the sea. And this is a problem because it's going to cause a rise potentially in ocean temperatures. Obviously, this is a sort of graphic that explains what's going on. If a cube of ice melts in a glass, the water level doesn't go up, Archimedes' principle. But if you have stacked ice sitting on the bottom that's supported by something other than the water, when that melts, the water level goes up. And it's impacting Pacific communities that are being inundated, the Maldives and so on. This is a great shot here. This is the south of England where I'm from. It's not supposed to be like that. This is a train running along the beach. In Alaska, we're getting erosion as a result, and in Atlantic Canada, coastal erosion is starting to occur, which is causing all sorts of problems. Again, in London, the Thames barrier has been raised more times. You can see this graph. I mean, it's really horrendous. This is a very obvious and major increase. Now, it turns out that the area that we're worried about is this area here. It turns out that if that area were to go, the West Antarctic ice sheet, what would happen is ocean levels would go up worldwide 3 meters. And unfortunately, we're starting to see problems. Much of this ice is, some of it is partially supported, some of it is floating, some of it is actually on land, and some of it is sort of a little in between. It's sort of floating, but it's stuck on the top of seamounts that are under the ocean. So the ocean can actually flow underneath it. And we're starting to see extensive snowmelt happening. And it's an area the size of the state of California. This is a big, big, big area. It turns out there's another area that's just about as big, Greenland, and that has similar problems as well. If Greenland were to melt, again, ocean levels go up 20 feet, 20 feet, 6 meters, I'm sorry, I think I misspoke earlier. If the West Antarctic ice sheet melts, they go up, again, 6 meters. If half of each melted, we're looking at a 6 meter rise. So this is a very, very serious issue. I'm going to skip forward here a little bit, because I know we're running short of time. What we're seeing in, let me just skip through this, I'm sorry, because I know we're going to be short of time. This is just a graphic that explains the ice melt and the process that's going on. Essentially what happens is pools of water appear on the ice. And remember what I was saying earlier, when the sun rays strike water, 90% of the energy is absorbed. So as soon as you get a little pool started, it runs away and gets bigger. And then these pools melt and actually tunnel down through the ice. And in Greenland, they create what are called moulins, which are these huge tunnels going right down to the bottom of the ice. And they, in effect, undermine and lubricate, if you like, the ice mass that's sitting on the bedrock, causing it to break and eventually slip off and potentially fall into the ocean. And we're seeing a tremendous increase in glacial earthquakes in Greenland as a result of this, doubled in the period 1993 to 1999, and then much worse, doubled again more recently. So Greenland is starting to melt. And this is really graphic and obvious. It's affecting Canada, of course. Both at sea, ice packs are breaking up. This is a great graphic. This shows you what would happen with a 6 meter rise in Vancouver. Not surprisingly, Richmond and Ladner are completely underwater, right up into the valley, completely underwater, so it would cause tremendous problems in Vancouver. We'd have to build a new airport for starters. This is what would happen in Florida. Much of Florida would be inundated. Again, in other parts of the world, Beijing, the same sort of thing. Shanghai, similarly. Now this is going to cause immense dislocation of populations. And this is sort of, this is the sort of stuff that's starting to worry people like Gwynne Dyer. In Calcutta, many, the people, they've got enough problems already with, they're impoverished and so forth, they're going to be inundated. Bangladesh, the same sort of thing. And this is what's going to happen to populations. Literally hundreds and hundreds of millions of people are going to be displaced. So there are really three factors causing this problem. The population explosion, the scientific and technological revolution, and our way of thinking. Now the population explosion is pretty obvious, but it's really within one generation we've had this sort of change, a massive, massive change in the Earth's population. I'm going to slip through this slide quickly. This is what Sarah Palin calls the first modern humans, and there we go, 250 million years ago. In the Middle Ages, that's where we were. In the 1776, in the war, Second World War, 2.3 billion. So just within, I was born in 1951, so just in my lifetime, it's gone from about 3 billion to 9 billion. It's tripled. And it's all happening, of course, in developing nations predominantly. And they're going to suffer the most from climate change. Food demand is going to go up. Gwynne Dyer talked a lot about this. This is an enormous problem. As countries become unable to feed their populations, it's going to cause tremendous stress and water demands and so forth. Here's where energy is being produced currently. And again, I want to skip through this fairly quickly. Very little renewable energy, a little bit of hydro, a lot of gas, a little bit of nuclear, a lot of oil, and a lot of coal. We need to change this because this is not a good scheme. This is causing a tremendous amount of pollution. It's also causing forests to be devastated and cut down. This is a great shot. This is the Dominican Republic. It's actually the border between Haiti and the Dominican Republic. So you can see what a difference political policies make. So on the one side, they've allowed everything to be chopped down. On the other, they haven't. It's a striking difference. Here's Brazil in 1975. Here's what it looked like in 2001. This is a sort of a shot that just shows the impact, the impact of animals and farming on the land. So that was Bolivia, same sort of thing happening. Forests are being burned, causing pollution. Again in Brazil, tremendous devastation. Trying to find more land to plant crops to feed people. And then of course we've had tremendous wildfires in North America, and we all know about what happened in Kelowna, where we had tremendous wildfires started by a lightning strike. But fueled by a constant wind, much stronger wind than we normally would have expected, and a very, very dry summer, a series of dry summers over the decade preceding this. Similarly in Georgia and Florida. Again, I'll skip through this. LA, huge fires. Just recently, again, huge fires in LA and Malibu. These fires were caused by high tension wires being blown together by the Santa Ana winds that were much stronger than usual and caused the wires to arc. That's happened again this year. This is a great shot that I'm going to show you. This is a composite image created by the US Air Force, taken at night. The red spots are actually, here in Africa, are actually cooking fires, which is really fascinating. The white spots are street lights. These yellow spots are actually gas flares from oil wells in northern Russia. And these blue dots here are the lights from the fishing fleet in the off the coast of Asia there. It's a wonderful shot. Here's a gas platform in northern Russia, and you can see that's what you're seeing from the air. So the second point, the scientific and technological revolution. Obviously, science is great, and it's done a lot for us. But there's a problem. When you combine old habits with old technology, you get predictable consequences. When you combine old habits with new technology, you get dramatically altered consequences. So again, in the old days when people went at each other with spears and so forth, the result was fairly predictable, gruesome, but somewhat predictable. It's the Battle of Agincourt, World War II. Little different when you start using new technology. Again, food and agriculture, it's the same sort of problem. In the old days with traditional farming methods, we got good use out of the land, but we didn't really rape it. In the old days, this is what a shovel looked like. Today, this is what it looks like. So, and this is even bigger. This is at the tar sands, I believe, in Fort McMurray. Massive shovels that are causing tremendous devastation and mining. Fishing, again, long liner fishing nets have devastating consequences, and especially when these nets break or become loose, they're drifting around the sea, untethered to anything, just catching stuff constantly. It causes tremendous devastation of the fisheries, of the ocean life. This is a great graphic that shows you how fisheries have just devastated. This is insane. I mean, we've completely devastated the fisheries all over the world by overfishing. Again, an enormous problem. Irrigation's a great thing, but when you overdo it, it puts tremendous demands on the water supply. Colorado River then, Colorado River now. This is the Aral Sea in Russia. This sea was formerly fed by two rivers that the Soviet Union decided to divert for irrigation for cotton crops. And the Aral Sea, which was I think the second or third largest inland sea in the world, dried up. And as the shoreline receded, the fishermen dug this canal desperately to try and be able to get their boats back to port and back out to the sea, and eventually they lost the battle. So you have this bizarre shot of ships in an apparent desert, which was once a great sea. Again, in the old days, this is how we used fire. This is what we're doing today. There's a great story about this shot. We were looking at this in the presentation, and one of our co-presenters, Peter Corbin, saw this shot, and he said, "Oh, that looks familiar to me." And then he realized that he actually used to live in one of these houses here. And his father actually helped build these plants. Apparently he's now moved on to nuclear, so Peter's a little embarrassed about it. But this is at Sellafields in Britain. It's a huge coal-fired power station. And this is, again, a great night shot. You can see what's going on at night, how many lights are being lit. Tremendous amount of energy being used to light all these lights up every night. This is a great slide. This actually shows you, it's a sort of computer-generated slide where we've expanded, I'll play it over again, and we've expanded the continents to show their relative impact on global warming. So, of course, not surprisingly, the US is a bad culprit. This is what it looks like per region in terms of carbon dioxide emissions. The US, of course, is the greatest. But we really shouldn't feel smug in Canada, because when you look at it on a per person basis, this is what it looks like. And in Canada, we're actually just as bad as the US. So we really need to do something about this in Canada. That's the average for the world. So we're way, way, way above average. Again, this is a great slide that shows regional greenhouse gas emissions by province. I was a bit, this is a projected growth, so this isn't an absolute number. This is the projected growth of greenhouse gas emissions by province. And I was surprised to see that BC has as high a projected growth as it does, but it's apparently because of oil and the various other things. And of course, you know, now with the pine beetle, it actually could even be worse than that. Canada increasing 26%, it's just not good enough. I mean, the Kyoto targets were measly to start with, and we're not even meeting those. And I'll talk a little bit about that in a minute. Gas emissions by province, of course, Alberta is the worst, and the biggest offender, of course, is the tar sands project. Now, when we were being trained with Al Gore, he was much more open about this issue in private than he would be in public, because it's a political issue. But the tar sands is a disgraceful, you can't put it any other way, it's a disgraceful exploitation of the resource, and they're disgracefully damaging the environment in Alberta, and it really needs to be stopped. Here are some sort of tar sands facts that I dug up. I'm just in the middle of reading a great book by Andrew Nikiforuk that I'll show you later about the tar sands. But 1 barrel of oil or its equivalent produces 20 to 60 barrels of conventional oil. In the tar sands, it only produces 4 to 5 barrels of bitumen. So the tar sands is a highly, highly inefficient way of trying to get oil. Here's the Syncrude mine in Alberta. Every barrel of tar sands bitumen creates 3 times as much carbon dioxide as a barrel of conventional oil. And it uses 3 barrels of water, which ends up in Taylor ponds. It actually uses about 13 barrels of water from the Athabasca River, which is one of the greatest watersheds and most important watersheds in the world. We're draining 13 barrels of water out of it to make every single barrel of oil, of bitumen. And 3 of those barrels end up getting dumped in these horrendous tailing ponds that are so big that you can actually see them from space. And there was recently a situation where a flight of ducks, because they can't tell the difference, landed on the tailings ponds. 500 ducks died. And in fact, every year, thousands and thousands of ducks and waterfowl die by accidentally landing on these tailings ponds thinking they're lakes. Just a few more facts. Oil and gas destined for the US accounted for 1/3 of our increase in greenhouse gases. This was from Canada's Environment Commissioner. Now that's approximately the same amount by which Canada failed to meet its Kyoto targets. So this oil and gas that we're digging up, damaging the environment, ruining our ability to meet Kyoto targets, we're not even using it. We're actually importing oil and gas. It's going to the United States. Now when Johann Jelinas wrote a fairly scathing report on this, of course she was immediately fired. As you would expect, and that was the end of her. So, you know, this is what a tailing pond looks like. It's absolutely horrific. It's horrendous. These things are miles wide. They originally thought that the clay would settle out fairly quickly. They put a mixture of sort of clay and oil and heavy metals and general nasty gunk into the pond. And they originally thought that the clay would settle out and they'd be able to clean it all up. They've now concluded that they were wrong, and they think it's going to take 1,000 years for the clay to settle out of these tailing ponds. So these are just a carbuncle on the face of the landscape in Alberta. What's even worse is they're digging up peat bogs and boreal forests, which are huge carbon sinks and absorbers of carbon, and replacing them with this. So it's got to stop. I mean, it's just a disgraceful situation. The Alberta government is completely out of control on this issue. They're holding security deposits of $5,000 an acre from people if they want to mine the tar sands. The only area that's ever been cleaned up, and it didn't even have a tailings pond, cost $46,000 an acre. So you can see where this is going. Also, you know, we're burning huge amounts of natural gas. I mean, this is what's so nutty. Some people say it's like burning a Picasso to heat your house. They're burning huge amounts of natural gas to get this very, very dirty oil out of the ground. We know that there isn't enough natural gas available. We'll have used up all the natural gas a long time before all the oil sands have been dug up out of the ground. So now they're saying, oh, well, no problem, we'll just put a bunch of nuclear plants up there to solve the problem. So this has got to stop. It's completely out of control, and it's a disgrace for Canada. So we really need to change our way of thinking, and this is a great graphic that Al Gore used in the movie. Here's the frog. Turns out if a frog jumps into a pot of boiling water, he immediately jumps out again. But if you put that frog into a pot of cool water and heat it up, he sits there and waits and waits and waits and waits and waits until he's rescued, because you have to look after the frog. There he is. So here are some misconceptions. Is there disagreement among scientists about whether the problem is real or not? No, there is not. There is not. The debate's completely over. Everybody agrees that this is a problem. Even George Bush latterly agreed that this was finally an issue. Now he was running out of time in office. It's the strongest consensus that's ever developed. We've badly underestimated the degree of damage from the risks of climate change. And everybody has to do something about this, particularly in Canada. We really, really need to get on the case here in Canada and deal with this. Here's a great stat. The number of scientific studies dealing with climate change published in scientific journals over the previous 10 years, it's more than that now. This was from 2004. The number disagreeing, they did a sample. The number that disagreed with the global consensus that greenhouse gas pollution has caused most of the global warming, 0, not 1. So this is not something that's in dispute. There are some great sites on the internet, so if any of you run into skeptics who say, well, yeah, what about this and what about that? Maybe we can get into it if we have time for questions, but there are some great sites on the internet that go through, hi Amber, I can see at the back there, that go through some of these things, and you can find out a lot of the answers to those questions. This was a great, of course, this is, thankfully we're hoping with Barack Obama in the White House, this is all going to become something we don't need to worry about, but the Bush administration, as we all know, behaved disgracefully on this whole issue. And this was something that the tobacco industry did. More doctors smoke Camels. So when you listen to guys like James Inhofe, the ridiculous senator from I'm not sure where he's from, talking about global warming, these guys are dinosaurs. And luckily, I think they're all going to be gone, mostly gone, or at least out of power fairly soon. So in fact, what's happening is that what the Bush administration was doing is they were going from the old tobacco industry playbook, and they were actually fairly successful. Again, number of reviewed scientific articles, number that said there was a doubt, 0. But if you look at the media, when you get CNN saying we've got somebody for, we've got somebody against, it's almost evenly divided. So the media is very good at taking a ridiculous position and a sensible position. A ridiculous position that almost nobody believes in, a sensible position that almost everybody believes in, and they put 2 people and give them equal time. Well, the public see this and they think, well, this seems like sort of even, so maybe you do, maybe you don't, point, counterpoint. Well, and it's really misled the public when they're interviewed. So it's no wonder that people are confused by this. And this is a great saying by Upton Sinclair. It's difficult to get a man to understand something when his salary depends upon his not understanding it. George Bush put a former oil lobbyist in charge of the environment. I mean, how ridiculous. It's an insult to everybody's intelligence. Do we have to choose between the economy and the environment? Of course we don't. This is a great slide from the geniuses at the press office in the White House. This slide down here in particular from a press briefing. It's sort of a funny one, and Al Gore talks about it in the movie, where they've got this balance, with gold bars on one side and the planet. It's a pretty tricky decision here. We need somebody with a clipboard to figure it all out and take notes. It's a ridiculous argument, of course. It's a completely ridiculous argument. And in fact, as we're now discovering, the green economy is really where we need to go. We're all hearing a lot on the news right now about General Motors and Ford and the big 3 automakers going bust. This is part of the problem right here. Here are the fuel economy standards around the world. There's Canada. Here's the US, pathetic. and this is driving the car companies. This is the oil lobby causing this. California tried to enact an amendment. This is China, incidentally, to increase the mile per gallon requirements of cars. The oil companies fought this in court because it was obviously, they said, a completely ridiculously high objective that we would have to, by 2016, make cars that are not quite as good as the cars that China makes today. Obviously, that's completely ridiculous and unachievable. Well, it's absurd. I mean, GM were talking recently, as recently as a few years ago, the president of GM was saying that he thought hybrid cars were a silly idea, This has got to stop, and the result is the market forces are going to take care of it because these companies are simply going to go out of business if they don't change their ways. And generally speaking, we'll skip through these, but generally speaking, the CEOs and chairmen of big companies are getting it. They're now starting to realize that a green economy actually is a good thing, and it's going to be something that we have to do. I think it's probably going to be the biggest creator of jobs in the latter part of this century. So the other problem that people say is, well, this is so big, I don't think we can even fix this anyway, so it's just a disaster. Well, it turns out that's completely wrong. The good news about this whole problem is that we already have all of the technology that we need to fix this problem today. We have everything that we need. With wind farms, with solar. Al Gore came up with a great stat that I thought was really, really, really wonderful. He said that if you made a solar field 100 miles by 100 miles and stuck it in the desert, somewhere where the sun shines, that would create enough electricity to power America. So that's not very big. I often fly down to LA and Las Vegas for trade shows and so forth, and when you look out of the window of the airplane, you can see vast areas of gravel where the sun's shining all day long with no people in them. So if we were to start building these solar fields, we could fix the problem. We have and it would create huge numbers of jobs. So this again is not rocket science. We don't need to invent nuclear fusion or cold fusion or anything like that. We can do it this way. And we've got all the technology to do it. We can create jobs doing it, and it's absolutely fixable. So this is where we need to get to. Again, this slide is pretty self-explanatory. It's the renewable energy future, and you can see that this is where we're at today. Here's how we can reduce it. By having some electricity end-use efficiency, little things like turning your thermostat down a bit if you have electric heat, unplugging appliances that are drawing power. A lot of appliances, TVs, for example, anything with a remote control draws electricity all the time, even when it's turned off. So if you start unplugging those or stick them in a power bar and just switch them off when you're not using them. Transmission, if we swapped out the transmission grid to more efficient transmission lines, we could get a tremendous amount of increased efficiency in electricity end use. We can reduce it this much. Going to better passenger vehicles. You can still have gas-powered cars, but make them be little cars instead of big cars. Something you really notice in Europe is everybody drives smaller cars. Even here in Canada, you really see it. Everybody's driving around in little tiny cars in Europe. A lot of them, I stood on the street corner where my mom and dad live in southern England. I was watching the cars go by. And it seemed like about a third of the cars were not only little, they were diesel powered, where you get double the fuel economy. So we need to just start doing that sort of thing more, particularly in America. In the US, they need to do it. Again, other transportation efficiencies. Renewable energy, of course, solar, wind, geothermal, and so on. And we're back down to where we need to be. We're back down here where we were in the 70s. So we can easily get there just by doing these things. And if we did some grander things like the solar field idea, it would make a massive, massive difference. Carbon capture and sequestration and supply efficiencies even more. There are some issues around carbon capture and sequestration that we could talk about later. It's not quite as clear that it's as benign as some people might think. But still, there are things that can be done. So now the question is, what can you do? Well, here's a bunch of ideas. You can save energy at home. You can switch to energy-efficient light bulbs. We did our whole house in West Van with these bulbs, and it's great. The new ones have exactly the same light quality as a regular. So the old, when they first came out, you looked like you were in a sort of laundromat, when you put them on. The new ones aren't like that. They're actually really quite good. So you can switch off the lights when you leave the room. That's a real simple solution. Trying to get that done in our house is a little tricky, but I now go around and I'm constantly turning the lights off because we've got lights burning in all sorts of rooms with no people in them. So that's a really simple thing that you can do, and it'll make a big difference. You can take shorter showers, something I'm learning to do with my wife's insistence. You can, if you want to, if you're really fancy, you can buy one of these new fancy shower heads where less water squirts out, but you still get a decent shower. Simple things. You can buy Energy Star appliances. So whenever you buy a fridge or a dishwasher, make sure it's an Energy Star appliance. We're just in the process of switching out our furnace at home. We've got an old furnace that isn't actually broken, but I want to get a new one, and we're going to switch it to a new Energy Star efficient furnace. And I'm told it's going to be almost 40% more efficient than the original furnace, because our furnace is about 20 years old. So that's something, it's expensive, but it's something that you can do, and it'll make a big difference if you have a house. Other things that you can do, I talked about this earlier, you can reduce standby power waste, unplug those things, anything that has a remote, when it's off, it's still on. So you need to some extent, so you need to unplug them to reduce standby power waste. You can buy a more efficient vehicle. If you can't afford to do that, you can just buy a carbon offset for the one you've already got. I've done that on my car. I drive a Mini, and my wife, unfortunately, drives a much larger car. She'd rather she wants a hybrid, but we can't afford it right now. But what I have done is I've offset all the cars. So you can actually go to a place called TerraPass, and you buy an offset, where you actually pay money. You go to the website and it asks you what sort of car you have and how many miles you drive a year, and it calculates the amount of gas that you would use, and then you can actually buy a carbon offset for that car. I think this is a really, really great idea, because if you just sell your car and buy a more efficient one, that car's not going to go into a scrap heap unless it's a really old car. Somebody else is going to just start driving it, just like you were. So I think there's a lot to be said for not selling the car and buying a hybrid. It's expensive to do anyway. Hybrids are great, don't get me wrong, but it's expensive to do that. There's a lot to be said for just offsetting the car that you already have. Make sure it's maintained properly, pump the tires up a little bit more. Everybody laughed at Barack Obama, at least the Republicans did, when he told people to pump their tires up. Well, it turns out it does make a difference. And if everybody did it, it would make a difference. It's good science. So there are things that you can do. These TerraPass things are surprisingly inexpensive. I think my Mini was like $60 for the whole year or something. So, and essentially what happens is when you buy the carbon credit, the carbon offset, that money goes to renewable energy, planting trees, and so on. So you're still creating the carbon dioxide, but you've actually paid money to offset it. So I think it's a really great thing to consider. Obviously, use mass transit. And mass transit's getting better and better now in Vancouver with the new line to the airport. And in a lot of cities in the world, where I come from in London, everybody uses mass transit all the time. I mean, I have a pal in New York. I was talking to him about cars, and his eyes were glazing over. And he said to me, "Well, actually, I don't drive." And I thought, "What?" And he said, "Well, I just never bothered, And a lot of people, he just used public transit all his life. So that's something that can be done. Fly less. Flying is I fly far more than I would like. I'm flying a lot less now. And I say to guys who are in business like me, everybody's quick to jump on a plane and fly across Hell's Half Acre to do a meeting. Oftentimes, if you just do a conference call, you can use free conference. It's even free. You can use you don't need to go. If you get yourself a good conference phone, eliminate the flight. It's less wear and tear on you and much less wear and tear on the environment. Frivolous flying I've got a real problem with. I won't get into it now, but I call it frivolous flying, where people are just flying all over the place There's so much to see just right here in BC. You really don't need to go anywhere. I know a lot of people do want to travel, and I did when I was in my 20s too, but there's so much to see just around here. So try and fly less. And it's really all about this. I talked about buying offsets already. This is actually my grandfather's kettle. So my mother says, this is a good English saying, she says, buy cheap and you'll buy twice. So buy stuff that's good and make it last. This kettle was actually his father's kettle. And for a while it was buried in the garden, and he used it as an antenna for his radio, right? And it still works, and I polish it, and we have it in front of our fireplace, but it actually works perfectly. So if you buy something of quality, it just buy less stuff, but buy good stuff, so it'll last you. And this just constantly buying stuff and chucking it out and buying again, chucking it out, buying again, don't do that. This is a much better idea. Eat less meat. It turns out that creating protein in animals creates way, way more damage on the environment than if you ate vegetables. So we're not saying don't eat meat. We're not saying everybody become a vegan or a vegetarian, but just eat a little bit less meat and more vegetables. And that's good for the environment. Buy goods that are made locally as well. Buy BC cucumbers, not the ones that come from Mexico, because there's a huge amount of fuel use. So just take a little bit of time when you're in the shops and just say, okay, I want to buy. It's good for our economy, and it's good for the environment. Composting, we've got one of these in our garden. This is great to do. I don't know if any of you have gardens, but composting is a great thing to do. It's great for the garden, and it's less stress on landfills. Having said all of that, if we do everything that we can do, we can really only impact on about a third of the problem as individuals. And as Al Gore says, big problems need big solutions. So really, the most important thing is we have to make sure that the people we're electing to government are doing the right thing, because they have the biggest impact on what we do. And it's just essential that we are individually, each one of us is really a catalyst for change. Part of the reason that I'm here doing this, talking to you, I'm hoping you'll go and talk to other people, and I'm hoping that some of you maybe will even know another group that you can get me a gig to go and talk to as well. Everybody needs to talk to everybody else and just get the awareness up. That's what this presentation is really all about. It's just raising people's level of awareness to the problem. You've got to take political action. We've got to have people running this country who get it, and the current group don't get it. I think with Barack Obama being elected into the US, they're starting to have to move a little bit more his way, and I think he's going to do the right thing. But the current gang don't get it. The Alberta Tar Sands project is a stark example of how badly they don't get it. So we need to make sure that people that you should vote for people who are going to do the right thing, but you also need to speak out and get other people voting for people who are going to do the right thing. Here's everybody who ratified Kyoto. And Stephen Harper was even talking at one point in time about unratifying it, even though we've ratified it, although we've made a pathetic attempt at trying to meet our targets. Was not ratified by the US and Australia. Australia had an election. They're on board, and now it looks like the US is going to hopefully get on board as well with Barack Obama in charge. We can only hope. We need to make sure that we do our part, though, in Canada. Locally, we're doing pretty well with all of these municipalities on board. Federally, not so good, but locally, the will is there. And we won't belabor this, but the point here is this is supposed to be a sort of an inspirational slide where we're saying, look, we've done all this other stuff. Let's fix this problem. And it absolutely is something that we can fix. It's just an issue of will. It's not an issue of technology. It's simply an issue of will, nothing more or less than that. Again, some big changes have occurred as a result of effort. We'll skip through these very, very quickly. A man on the moon. If we can do that, we can surely fix this problem. The CFC, the hole in the ozone, was an enormous problem. Many people thought it was unfixable. Now, as a result of efforts that have been made, there's been a tremendous success story. And chlorofluorocarbon production has dropped dramatically. And we're well on the way to fixing the problem. So this is the This is really the point here. This is a great shot here, if I can play it, of, again, this was taken by the Galileo spacecraft as it was heading out into space. Carl Sagan said, turn the cameras around, let's get one more shot. And then later on, when it was, I think, 45 million miles out in space, he took this shot back, pointed the cameras just before it went out of range back at Earth. And there we are here. This is the Carl Sagan's famous pale blue dot. And there's a lot of space around us. That's our home. It's our only home. And we've got to do our best to look after it. It's absolutely critical. So that's really it. What I'd like to do now is take any questions, and Amber Church is here. Amber, why don't you come up? So Amber is probably would have been better if she'd given the presentation, but anyway, you got me instead. But Amber's here as well. Amber was also trained by Al Gore in Montreal, and now you're studying glaciers. I got it wrong, right?
So I'm a master's student here at SFU, and I study glacial retreats and climate change in the Yukon.
I brought in the big guns for the question period, you see.
Oh, I have a mic. I study glacier retreat and climate change in the Yukon and the effects on northern river systems as well. My 2-second brief background is I am also a climate action facilitator for the Ministry of Environment, for the BC Ministry of Environment here in Metro Vancouver. I was trained with Al Gore with Nick. I was part of the official youth delegation, international youth delegation for the United Nations climate change meetings. So I have negotiated climate change at an international level as part of the official youth delegation to those meetings. And I also work on adaptation to climate change with a group here at SFU. And lots of work with NGOs and works with climate projects. So that's who I am and why I'm now standing up here as well.
Good. So let's see if anybody's got any questions, we'll do our best to, I'll do my best to get Amber to answer them. So, no, I'm just kidding. I'll try to. Right. Just get my water.
I think with this issue, it's obvious that like right now in the world we've reached a carrying capacity in various aspects, and this is one kind of dimension of it. Sorry, my voice is really bad right now. And I'm just curious, when it comes to the international, economy, it's a competitive playing field, and this is a cooperative initiative. Sorry, terrible. Anyways. I'm just wondering if that is something that needs to be considered. Is cooperation is required for this, and right now we're in a competitive international economy, and so it's completely two different paradigms for individuals, businesses, and governments. So I'm just curious if anybody's kind of thought about that.
Go for it. Yeah.
Okay.
Yeah.
All right. So a couple points there. In terms. Yeah, no worries. In terms of the competitive economy, I don't know if you guys have heard about what Europe is doing with their cap and trade system. So we are now essentially working in a system in many countries of the world where there is not only a price on carbon, but it's traded in the same way that we trade anything on the stock market. So there's a value, and what happens is, essentially in a cap and trade system, the idea is that there's a certain amount of credits that are available, carbon credits, essentially a right to pollute. And everybody has a certain level of those. If you are a green company, you don't need those. You can sell them to the highest bidder. If you are a company that is polluting, it's going to cost you to buy them from someone else. Each year, the number of credits available goes down, so the cost of carbon goes up. Eventually, it makes more economic sense in a competitive market to improve your industry and the amount you're emitting than it does to keep emitting. So essentially, we are putting a price on pollution. The carbon taxes that we've got here in BC are attempting to do the same thing, but they're doing it blanket across the board, so you are also charged, for example, for driving your car. So many areas are actually implying both, so that it both targets consumers, but also essentially industry ends up getting a double charge, because the cap and trade goes for the big industrial polluters. So that's one way to work within the competitive system. It's working incredibly well in Europe. People are making a lot of money off of it now. Here in BC, we do have the carbon tax. As you know, they tried to bring it in federally if the Liberals had come to power. The Liberals did not come to power, so we will not yet have a federal carbon tax, although some provinces are instating one, BC being the first. Ontario is working that way as well. We also, in terms of cap and trade, California has been spearheading a cap and trade system for North America. BC has signed on to that. So is Manitoba. I think Ontario is getting involved as well, and quite a few US states. So I think within the next few years, we will see this go international. Various areas of the world have their own. Australia has their own system. The difficulty we're working through now is trying to figure out how to do it internationally, so there's one set price on carbon internationally. So that's, in terms of your competitive market, that's the answer there. In terms of cooperation, I think internationally there's a very strong recognition for that, and that's what the UN process is about. So the United Nations Framework Convention on Climate Change is what you guys hear about every year with they're called the COP meetings, which are the convention of the parties. The next one is in Copenhagen, starting in a few weeks. That's where all of the parties come together. Every country, pretty much every country in the world comes together to try and negotiate the international process, and it is all about cooperation. It is very, very slow. I have literally watched a room full of incredibly brilliant people discuss the word "the" for 3 hours. And that sounds awful and insane, and it's incredibly frustrating when you know how fast the action needs to occur. But that word "the" means something very different to Saudi Arabia than it means to China, than it means to Canada. And in order for cooperation to work, there is a certain amount of, it does have to go at a certain pace because you actually need everyone on board. If you don't have buy-in from all the parties, it won't make any difference. That's what happened with Kyoto. We didn't have all the buy-in from everybody involved. When the US didn't sign, we didn't have a hell of a lot of leg to stand on, to be honest. So we're working towards consensus-based decision-making to make sure that everyone buys in, everyone agrees, and everyone moves forward. Hopefully now with the change of government in the US, we should see some really good forward movement in Copenhagen because they've been the ones dragging their feet the most. Canada is now the ones dragging their feet the most. So if you really want to do something right now, you should be writing to our politicians now and asking them to take positive action in Copenhagen because suddenly we're the ones left out in the cold going, no, we don't want to do it. There you go.
Yep, thanks, Amber. So, I mean, we're the bad boys, and I'm hoping that, I think the way the tar sands problem is going to be fixed is by forcing them to pay what they should be paying for the carbon that's being emitted, because the true cost of tar sands oil doesn't include fixing up the environment. They're not factoring that in, which, somebody's going to have to pay for that. It's probably going to be us, And as I showed you on one of my slides, it's incredibly polluting. So this really needs to be done. But carbon credits are going to be traded in Chicago, right?
Yes.
Which is great. I'm starting to work on a project. I need to talk to you about it in Africa, actually. And there are tremendous opportunities in Africa for developing countries to plant crops where they were not planting them before and get carbon credits and create jobs and so on and so forth. So there's, when you start thinking about the green economy, I'm an entrepreneur. When you start thinking about it from an entrepreneurial standpoint, it's just actually, it's best at times, worst at times. I mean, there's going to be huge opportunities for both us here in the developed world and in the developing world to actually sort of get on our bikes and do something about this and create a lot of work and wealth in the process. Anyone else? Yeah.
We've got a mic coming your way.
Thank you. I guess this question is kind of related to what you talked about now. I'm just thinking about developing countries and the way that what they care about the most in those countries will be cheap energy. We are talking about a lot of solutions here that are expensive, but that people here can afford. But how can we provide these solutions to people who currently cannot, and how can we make this beneficial for them to buy?
Great question.
For sure. So that's an amazingly good question, and it has a huge number of facets. To start off, you do hear a lot of things in the news about people yelling about China and India because of their population expansion, and you hear, a coal plant a week in China. And it's true. But as you guys saw in the slideshow, their per capita emissions are incredibly, incredibly low. So we are doing much more damage per person than they are. That plays into how can we help them get to our standard of living without going through the same process we went through. Because we're actually now, we don't want to lower our standard of living, but we do have to change our carbon footprint. And we need to get them to our standard of living without getting them to our carbon footprint. How do we do that? Okay. So part of the UN process is specifically to deal with that. And for example, the penalties involved in not meeting your targets, part of that was to shift those funds to the developing world to be able to help them make those advances. When Nick mentioned the green economy is becoming a very, very real reality very quickly. And the developing world is very aware of that. China has actually already switched 18% of their national economy to a green economy. Canada is nowhere near that yet. So they are they are well aware of it, and they're going there first. They're actually starting to lead the way.
Because they need to.
Because they need to.
Yeah.
But that doesn't mean we shouldn't be helping them get there. And we very much have a moral and ethical responsibility to get them there, because they are the ones that are going to be most adversely affected by climate change. You've seen pictures of flooding and the areas where sea level rise is going to wipe out, in some cases, whole countries. Tuvalu will lose their entire country with 1 meter of sea level rise. Can you imagine your whole country being gone? Mm-hmm. So we have a responsibility, and we should be working through our foreign assistance programs to get the money to them and to target it towards things that will help them with this it's not an emerging issue, with this issue.
I think I agree 100%. I mean, I think it's now our obligation. We've had the big party and made a huge mess, and now it's their turn, and it's our obligation to help them. We have to help them. Yes, I mean, we've just got to get used to it. We've got to help them. But again, there are opportunities there. You know, we could here in North America, we could be developing technology, and to help fix these problems and help generate green energy and so on.
And the other sort of point to that is that we can actually make money helping them through carbon economies and through offsetting programs, for example. A lot of people in Canada even right now are making money through, like, their business is offsetting. And so they are actually offsetting our carbon footprint by helping install technology in developing countries. So for example, often if you buy an offset right now, what it's going to do is put in wind farms in a developing nation, or switch over to high efficiency wood burning stoves. Right now, a lot of countries in Africa just have very, very low efficiency wood burning stoves. And even just switching to a high efficiency wood burning stove almost cuts their carbon footprint in half. There's actually a high school in North Van that has set up their own offset program for their students and community members, and those donations are going straight to schools in Africa and switching over their stoves, and they've been very successful. There's huge numbers of programs out there that are trying to do this while still actually, you can make money doing this. You can make money helping them.
So, I mean, you know, that slide that I showed of the cooking fires in Africa, they shouldn't be cooking on fires. They should have a little stove of some sort, which could be easily manufactured and provided to them, and it would enable them. They wouldn't require as much fuel. It would be better for cooking. I remember when I was in Africa, and I think they're still doing this, they were cooking on a plow wheel, where they get a wheel off an old wheel off a plow, which has 3 holes in it to fix it onto the plow. They put 3 bolts, 1 in each hole, and it's sort of like a wok, and they light a fire underneath it and cook on that. Well, it works, but it's not very efficient. So we could, for not much money, provide them with something like that, and it would make a big difference to their lives. But there are huge opportunities. I think that, you know, we're going through a time that's really transformational, where we have to make these changes. It's not optional, and it creates an enormous opportunity for business people and for engineers to figure out new technologies and new products. So I think we're actually entering one of the most exciting times for a long time in terms of entrepreneurial development. I actually think that the green economy is going to take over from the whole computer thing was what I grew up with and where I made my living, and that was the the big deal, of the 20th century. I think the green economy is going to be the big deal of the 21st century. So that's where where you need to be thinking about getting jobs and working in firms. It's going to be an enormous, as we have to green up the world. It's not optional. As Amber said, in China, the reason that they're doing it in China is not because for altruistic reasons or because they heard Al Gore's presentation. It's because they haven't got enough energy. They need to do it. They don't have any choice. So there's an enormous opportunity there.
Yeah, and in terms of that opportunity, I think my generation, and the majority of most of you are in that generation as well, we're in many ways the first generation that grew up knowing we were going to have to do something about this. I was writing political letters at 5 years old, and I know I'm not the only one who was. And the paradigm shift is coming with us, because we care enough to do it. And now we're lucky that there are people in the generations before us that get it as well and are helping to support us. But we are now coming into a phase of our lives where we are the people running the businesses. We are the people running for office. And we are the ones who are going to be making this change. And unfortunately, we are also fully responsible for that. If we don't make the change, well, we'll probably be past the tipping point. So it's a little bit heavy to put on our shoulders, but we don't have a choice. We have the choice to rise to the occasion, or to stand back and watch it burn.
Mm-hmm.
Jen.
Yes. Take at the back, and then we'll...
Okay, I have 2 questions. First of all, is there a rising political person in Canada that we should be supporting? And who should we be writing to with those letters more immediately? That's my first question.
Okay. Well, we'll do that one first. There was a rising political person. He's just resigned the Liberal leadership. Unfortunately, Stéphane Dion actually was incredibly, incredibly progressive. He just couldn't manage to project that to the Canadian public. And he didn't do particularly well coming across on a television screen. He did incredibly well in person if you ever got a chance to see him, but that's no longer an option. So we're going to have to wait and see what happens with the Liberal leadership race, and in terms of what they come out, if the green shift is still a reality or if they're going to move a different direction. Obviously, the Conservatives are not there yet. Elizabeth May is incredibly, incredibly well-spoken, very smart and very intelligent. Unfortunately, the Green Party probably isn't going to take power yet. And the NDP sits somewhere in the middle. So I know that's particularly great news. Yeah. In terms of those letters, you should definitely be targeting them to the Minister of the Environment, our current Minister of the Environment, and our Prime Minister, because those are the people who will actually be representing us and negotiating for us at COP. Especially the Minister of Environment, that's actually one of his duties. So definitely you should be bombarding him. That said, you can also write to the environment critics for the other parties, because they will all also be at COP, and they'll be doing everything they can. They won't be the official voice, but they'll be doing everything they can behind the scenes and in the back rooms. So if you give them their support, that gives them just that much more incentive to try and do everything they can.
It looks like, I was listening to the radio this morning, Michael Ignatieff has thrown his hat in the ring, and it looks like he's going to probably be it for the Liberals. So we need to start writing to him. Obviously, you've got to write to the person that you think is going to get elected. Sadly, Elizabeth May was great, but she's just not going to get elected. Jack Layton was pretty good, but although he softened on the tar sands thing a bit, I was a bit disappointed by that. Yeah. He was looking good for a while. Then he lost the plot a bit, I think.
He did a few things at the end.
Yeah, that was not too good. So you've got to write to the people you think are going to get elected, and if none of them are any good, you should run for election. What we need are new people doing it. These old guys are not. They don't get it. So we need some new blood in the system. So I don't know what Trudeau's son is running. I don't know what he's. Yes, I haven't heard much about him. Is he? Justin
Trudeau is a very good option.
Yeah.
He definitely has a very strong environmental and social conscience, and so we've got some hope there.
I wish he'd run for the leadership.
Yeah, he might eventually. I don't think he'll do it yet.
Not yet. Yeah.
But he is now in office. He did win during the last election, his riding. Elizabeth May, for very moral reasons, chose to run in a riding that she knew she wasn't going to win. It's been conservative for generations. It's actually been passed father to son in Nova Scotia. That riding has been conservative for almost 60 years. But she felt it was important to run in her home riding. Now that said, I think she did a pretty good job of stirring things up at the debate. But at the moment, we are in a slightly tricky political situation in terms of voting as well, that in many ways we have a two-party system. That said, the Bloc can control Quebec, and the Bloc actually has much more progressive in terms of environmental opinions than the Conservatives, so we're actually better off with them in power there. And the NDP takes a portion of the seats, but they probably aren't going to win. And so and the Greens, at this point, don't have a seat. So we have this issue that we've got two parties, and we can split our left vote, or we can strategically vote. And there was a huge move to strategically vote in the last election, and it did work very well. It definitely kept the Conservatives in a minority. People think that that was probably the reason that they did not win their majority, was the strategic voting. But we still need a party to win enough to become the leading party. So we're in a frustrating situation right now. But the more pressure you put on, the more public voices they hear on an issue, the more likely they are to act on it.
What do you think about proportional representation? I was a bit disappointed. I mean, we made a mess of that. You know, it wasn't explained to people properly.
Does everybody in the room know what proportional representation is? Do people get it?
Yeah.
Yeah? Okay.
We'd have some Green MPs if we had proportional representation. So basically, instead of everybody, you know, we're in this ridiculous situation in Canada. We're not supposed to talk about political stuff, but we're in this ridiculous situation in Canada where the majority of people don't vote for the party that gets elected, that's in charge, you know. So proportional representation is a system that they have in other countries. They have it in Ireland, for example, in Southern Ireland, in the country of Ireland. And it basically means that you vote for the person you like most, and then the person you'd like next most. I mean, that's the simple explanation of it. So, and then so people that are a lot of people's second choices can actually get elected and actually get a seat. So I think something like that would, personally, that's my personal opinion, I think that would be a good idea, because then we could get, you know, I think it'd get more people engaged, and you get people like Elizabeth May actually being in the House, which would be great. Mm-hmm. One more question. I know we're getting short on time, as I know you had your hand up.
This will be the final question, then we'll have to wrap up.
Thanks.
But you are welcome to ask us questions
afterwards. Absolutely. Yeah.
Well, yeah, I think it's much easier to take my own responsibility instead of persuading those pink hats in the government. Well, I've been wondering, how is it possible for us to reduce our emission level to zero? And even we do, how can we start removing carbon dioxide from the atmosphere?
Okay. How do we get to zero? At the moment, there are people living carbon neutral lifestyles, but they are doing that with a heavy reliance on offsets. At the moment, we aren't quite there in terms of not the technology not being there, but the technology being publicly available and affordable to be able to do it completely on your own. So a lot of people right now who are quite a few people out there who are carbon neutral, but they do have to offset to get there. So that's what you can do right now. All of the things that Nick listed are ways that you personally can get there. So changes in your electricity use, in your water use, in your eating habits, local, organic, less reliance on meat. If you want to go there, vegetarian. If you really want to go there, vegan. All really do make a huge difference. 8% of the global greenhouse gas emissions are from cattle that we eat. It's a huge chunk right there. It actually starts to rival the amount from transportation. Changes in your transportation uses. All of those things will start to get you there, and you can offset the rest to get to neutral. As our governments continue to push, and the public continues to push, and more importantly, the business sector, who is going to push regardless of if the government or the public do anything, because it makes financial sense for them, it will become easier and easier to do that without offsetting. I'm sorry, I think there was a second part to your question, and I've now missed it.
Yeah, I was asking, how can we start removing?
How can we start removing? Okay. There's actually a huge amount of research coming out of Alberta, mainly because of the tar sands, on how to pull carbon out. Some people push for the carbon capture and storage, which is to pull carbon out and store it, for example, in oil wells. Other people are now looking at, there was some cutting edge research in the University of Alberta and University of Calgary that's looking at other ways that they think they've found ways that technology can draw it out and store it in other forms. That's at the experimental stage. So it is starting to push there. Carbon capture and storage has been shown to work. So that is one way that we definitely will be going, I'm sure. At least, and I'm sure part of the solution, although there are issues around it, it will probably still something that will come into effect. So we will be using, for example, old oil wells, tailings piles from mines. At least certain minerals actually react with the carbon in the atmosphere and actually can be incredible sinks. Forests are incredible sinks. There are issues with planting trees as offsets, but that said, forest vegetation, plant life does draw down CO2, so there are huge tree planting campaigns as well. For example, the province has just started something called Trees for Tomorrow. It's a 5-year plan, and they're giving out grants of huge amounts of money for urban spaces, so schools and universities. Everyone should listen up there. Hospitals, institutions, public green spaces to have planting campaigns, and they will give you everything you need to do it. So that's another place where people are trying to make progress, is urban afforestation.
Thanks, Amber.
You're
Thank you
welcome.
very much. Thank you.
Thank
Thanks.
you very much.